So here we have a question on molarity. Let's see what the question says. Find the molarity of a solution made by mixing equal volumes of 30% by weight H2SO4, density is this, and 70% by weight of H2SO4, density is this solutions. Okay. The very first thing that you have two solutions given here. Let's say it is solution 1 and solution 2, right? Let's see this question in this fashion. So for solution 1, the percentage is 30%, and for solution 2, it is 70%. And you have density of solution given to us as 1.218 and 1.61. 1.218 gram per ml, and here density of solution is 1.61 gram per ml. So this is the information that we have. Okay. See, let's write the formula for density. What it is? Density is weight by volume. So can we say weight will be density into volume? So let's assume the volume for solution 1 and solution 2 to be V1 is equal to V2 is equal to VML, right? For both of them, the volume is VML, right? We have assumed it. So density will be 1.218 gram per ml into VML, right? So from here, WS weight of solution 1 will be 1.218 V gram, right? Similarly, you can calculate W2 weight of solution 2 will be what? Density is 1.61 gram per ml, volume is VML that we have assumed, so it will be 1.61 V grams, right? Okay. Now see this. How are we going to use this 30%? Can I say that if 100 gram of solution is there that has 30 grams of solute, which is H2SO4 here, right? So if 100 gram has 30 gram, then 1.218 V gram of solution will contain 30 by 100 into 1.218 V gram of solute. If you're gonna calculate this value, it will be like 3, 8, 3, 24, 2, 5, 3 to 6, 3, and this will be 0.3, 0.3654 grams, right? Same we can do it here. If you want to calculate like what? 100 gram of solution will contain, we have the percentage here as 70%, so 70 gram of solute. So what will be the mass if you have 1.61 V gram of solution? It will contain 70 by 100 into 1.61 V, right? And we forget V here, so V has to be there. This was V grams, here V grams, right? So if you just calculate this value, this is going to be what? 7, 7, 6, 42, 4, 7, 11, 1.127 V grams. Do not forget this V, very important. Okay. Now you have WS1, weight of solute 1, and W2, right? Okay, fine. Can we just calculate the total weight of solute now? This will be what? W1 plus W2. What are the values? 0.3654 V, 3654 V plus 1.127 V, 1.127 V grams, right? And this is going to be what? If you just add them up, 4, 7, 5, 12, and you have 6 to 8, 9, 3, 4, 1.4924 V grams, right? Okay, makes sense. And what is the molar mass of H2SO4? Can you just calculate that very quickly? It will be like 2, sulfur will be 2 for hydrogen, 2 hydrogens. Sulfur is like 32 and 14, 4. 16 into 4 is like 64. So this will be what? 998 gram per mole. So can we calculate moles of H2SO4 from here? Very simple. Moles, the formula for moles is given weight by molar mass. So this will be what? 1.4924 V upon 98. You have the moles, right? You have to calculate molarity, moles upon volume of solution in liter. Okay. Remember, you have assumed volume as V1 is equal to V2, V ml. So we have to convert that into liter. Don't forget that point. So if you do that, moles are coming out to be 1.4924 by 98 V upon volume of solution be V plus V, because you have assumed V volume for each solution. So total volume will be V plus V, 2V, and you have to convert that into liter. Okay. Okay. If you solve this, V will be cancelled with V, and 1.49 upon 98 into 1000 by 2. If you're going to calculate this, this value is going to be 7.61 molar. So let's look for the options, and option B says 7.61 molar. So option B is going to be the correct answer to this question. Yeah, so here you have a very sweet and simple question on hydrogen spectra series. Let's see what the question says. The series which has the lowest wavelength, that means lambda has to be minimum. Okay. And the option says Lyman series, Balmer series, Bastian and bracket series. Okay. For Lyman series, N1 has to be 1. For Balmer, N1 has to be 2. Bastian, N1 has to be 3. And bracket, N1 has to be 4. Fine. Okay. Now you have to focus on minimum wavelength, that is the lowest wavelength. See, if you observe what happens in the atom is, say, let's say this is first shell, right? And you have multiple shells till infinity. If you observe that energy is inversely proportional to lambda, right? So if lambda has to be minimum, then energy has to be maximum. And maximum energy, for maximum energy, the electronic transition should be from infinity to first shell. This is the maximum energy possible in hydrogen atom or hydrogen like atom, right? So the electron should move from infinity to the first shell, then energy is going to be maximum. And when energy is maximum, you will have the lambda as your lowest lambda possible. And if the electron is finally entering in the first shell, then the series to which it belongs will be what? Lyman series. So option A is going to be the correct answer to this question. And with that, we conclude this question. Thank you. Yeah, so here you have a question on shapes and geometries. Let's see what the question says. Which of the following pairs does not have the same shape? Does not have. Okay. And you have 4 options with different pairs. Let's do it one by one. If you look for option A, H3O plus and ammonia is given. So if you go by hybridization formula, it will be like 1 by 2 V plus M minus C plus A, right? What is V? Valence electron. What is M? Monovalent atoms. What is C? Charge of cation. What is A? Charge on anion. Okay. If you go for H3O plus, it will like what? 1 by 2. The central atom is oxygen, valence electron 6 plus 3 monovalent hydrogens plus 1 is the charge, so it will be like minus 1. 6, 3, 9 minus 1, 8, 2, 4. That means tetrahedral geometry. And for tetrahedral, you'll have oxygen and you have 3 hydrogens, right? So you have hydrogen 1, 2, and 3 with 1 lone pair and a positive charge. So this is what we have as H3O plus, and the geometry or the shape. Geometry is tetrahedral, shape is pyramidal. Okay. If you go for NH3, NH3 is what? Nitrogen 1 by 2. This is for NH3. And what we have 1 by 2. Valence electron for nitrogen is 5. Hydrogen 3, 5, 3, 8. No charge. So 8 by 2, 4. Again tetrahedral. So let's see for NH3 it will be like what? Nitrogen, hydrogen, hydrogen, and hydrogen. Oh, this is again pyramidal. Okay. Although this case is very famous, you might be knowing it already. So NH3 and H3O plus, same geometry, same shape. Cannot be the answer. Let's look for NH4 plus and CH4. NH4 plus. So it like what? 1 by 2. Nitrogen is like 5. Hydrogen 4 minus 1. 9 minus 1, 8. 2. Oh, sorry. This is like 8 by 2. 4. 4 is again tetrahedral. So nitrogen, hydrogen, 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 and hydrogen with a positive sign. The another one is what? CH4. So this will like what? 1 by 2. Carbon is how many valence electron? 4. So 4 plus 4 monovalent hydrogens will be like 4. Again tetrahedral. So the geometry will be like tetrahedral geometry. And because there are no lone pairs, geometry will be similar to shape. So you have tetrahedral for NH4, tetrahedral for CH4. NH4 plus and CH4. Both have the same shape. Cannot be the answer. So let's move on to the next. You have I3 minus and XeF2. Okay. I3 minus and XeF2. Let's go for I3 minus. 1 by 2. Valence electron for iodine will be 7. 2 monovalent iodines, 2 minus 1 will be plus 1. 7, 3, 10, 5. 5 is like what? Trigonal bipyramidal, and you have iodine and iodine with 3 lone pairs. 1, 2, 3, 4, 5, 6 with a minus sign. So this is linear basically, right? Okay, let's look for XeF2. This is what? 1 by 2. Xenon is like 8. Fluorine 2. 8 to 10. 5 again. Trigonal bipyramidal. And you have again xenon, fluorine, fluorine, and 3 lone pairs. This is again linear. So, cannot be the answer. The last option left, obviously this is going to be answer, but we have to check it for XCF6 and SF6. Okay. XCF6 and SF6. Let's do it 1 by 2. Xenon is like 8, 6 fluorine, 8, 6, 14, 2, 7. 7 is what? Pentagonal bipyramidal. So, and you have 6. Okay. 1, 2, 3, 4, 5, 6. And the 7th one will be a lone pair. So, the shape will be somewhat distorted octahedral. Right? XeF6. Let's check for SF6. It will be like 1 by 2. Sulfur is 6 valence electron plus 6 monovalent fluorine. 6 is 7, 6. There's a difference. sp3d2. This is what? This is like octahedral geometry. And because there is no lone pair, you can say the shape will also be, shape is going to be what? Octahedral. So here it is distorted octahedral and SF6 has octahedral. So there is a difference of shape and we were looking for that pair which does not have the same shape. So option D is going to be the correct answer to this question. And with that, we conclude this question. Thank you. Yeah, so here we have a question from states of matter. Basically, the compressibility factor. Let's see what the question says. If the temperature of the gas is lower than Boyle's temperature TB, okay, so the temperature of the gas is lower than TB, Boyle's temperature, then what are the options? Option A says At very low pressure, Z decreases with pressure. Okay. At very low pressure, Z increases with pressure. Okay. At very high pressure, Z decreases with pressure. And option D, Z becomes independent of pressure. Okay. See, there are multiple ways by which you can approach this question. You can do it mathematically, conceptually, but the easiest way to solve this question is graphically. So let me do it for you. Let's draw the graph of Z versus pressure, right? If you remember, this is Z is equal to 1, and for this is Z versus pressure, right? So the graph of the gas that comes out to be is like this, somewhat like this, right? Okay, okay. Now let's read the options and try to analyze what is happening with Z as we are changing the pressure. So at very low pressure, let's mark these points, low, high. This is point A. This is a point where the pressure is very low. This is the point where the pressure is moderate. Point C. This is the point where the gas actually behaves like an ideal gas. So what is Boyle's temperature basically? Boyle's temperature is that point where gas behaves like an ideal gas, right? So point C, the temperature corresponding to point C might be Boyle's temperature, right? Okay. See, option A says at very low pressure, Z decreases with pressure. At very low pressure, that means we are talking about point A. If you are at point A and you are slowly, gradually increasing the pressure, you can observe that Z is decreasing. And the option says Z decreases with pressure. That means this option is true. Look for option B. At very low pressure, again we are talking about point A. Z increases with pressure. No. Z is decreasing. Incorrect. False. Okay. Option C says at very high pressure. That means we are talking about C or above C. Z decreases with pressure. Observe this. At very high pressure, Z is increasing with pressure. So, no, this is incorrect. And Z becomes independent of the pressure. This is a vague statement. We can see Z is varying with pressure. So, the correct answer to this question is option A, which says at very low pressure, Z decreases with pressure. So, option A is going to be the right answer to this question. And with that, we conclude this question. Thank you. Yeah. So, here we have a very sweet and simple question. Let's see what the question says. In a given energy level, the order of penetration effect of different orbitals is okay. They're talking about penetration effect. See, what is penetration effect? It is the closeness of a shell or a subshell to the nucleus, right? How close you are to the nucleus, more will be the penetration effect. Okay. They are talking about a given energy level. That means N has to be same. And you have to compare SPDF. Different orders are given in the option. Fine. Let's say that N is equal to 4. So we are going to compare 4s, 4p, 4d, and 4f for the sake of example. Okay. You know that 4s has a lower energy level. You apply the N plus L rule. 4s has lower energy level. So 4s will be closer to the nucleus as compared to 4p, 4d, and 4f. That means the penetration power of 4s is going to be higher than 4p, then 4d, and then 4f. So if you generalize this for a given energy level, the penetration effect, order of penetration effect is going to be S, P, D, and F. Now let's look for the options. You have FDPS in the reverse order, and this is matching with what we have calculated. So this is going to be true. All equal, no. SPDF reverse order, no. And PSDF, no, not at all. So option A is going to be the correct answer to this simple question. And with that, we conclude this question. Thank you.